Alright everybody, so this is probably the most critical part of the whole engine rebuild. Getting your liner protrusion set correctly. I'm going to go through here and explain to you how to set it, what you're setting, what things ought to look like, and just the whole function of liner protrusion and shimming and cutting counter bores and all that stuff. So what we got here on the number 1 cylinder is the block's all cleaned up and the counter bores have never been touched on it before. This block has about $1.4 million on it, a little more than that possibly. It is ready to have the liner protrusion checked on the whole block, but this one never been cut. We go back here to number 6 and you ought to be able to see there where the block deck has been cut down, and so that has made room for a shim to go in it. So here's our shim. It's just a stainless steel ring, machined precisely. You can get these in different thicknesses. This one's, without miking it, I'm guessing it's 31 thousandths probably. But anyways, it's what came out of it. So we stick that back in there. There's a little chamfer right there on the outside edge. And so you put that with the chamfer down and you make sure that that cut area of the block is extremely clean. You don't want the slightest contaminant there, or it'll throw off all your readings and also have the potential to crack the liner if you do your final assembly that way. Now right now we're just putting the liners in without any seals or anything on it. Just this is a test fit. So the whole deal with liner protrusion is when you put the assembly together, which you got your bare block, you got a shim gasket that goes on next, and then on top of that you have a spacer plate. Now when the spacer plate is on and clamped down, it should be almost flush with the liner right on the outside edge of the liner. And so that liner, the wider flat part there, is where the head gasket fire ring sets. And that fire ring is the most likely place to fail if you don't get the protrusion right, because inside your cylinder you got a combustion going on, and that fire ring has to seal between your liner and your head. And what keeps it from blowing out, because that's a huge amount of pressure in there, is you got to crush that fire ring tightly. You got to get it tight enough that it won't blow out, but if you get it too tight, it'll put too much pressure on the edge of the liner and it'll crack the liner flange. So Caterpillar specs say that that you need between 1/1000 and 6/1000 protrusion in order to meet their specs. That's not sufficient. If you want it to hold, you really need between 4 to 6, and if you're putting out much power at all, you need it as close to 5.5 to 6 as you can get. It's the more power you have, the more likely it's going to blow out, and so that's why we've taken to fire ringing the heads, which basically is just machining a groove in the head and putting a little wire in that groove, and that little wire sets on that fire ring and gives it an additional little bit of pressure and locks it into the head, reinforces the ring from blowing out. And so on a fire ringed head, we want more like a protrusion of 4.5. So anyway, from factory, if you got a brand new fresh block and it's machined perfectly flat, and then you put the shim on and you put the spacer plate on and you measure your liner protrusion, I'm pretty sure it comes out to 3.5 thousandths protrusion, which it's middle of the road. It's not as tight as we like to see them. And so that's how they start out from the factory when you buy your engine. But over time, generally the blocks tend to wear, and the liner can wear into the block and sink in, and certain blocks over certain years are softer than the others, and you have more of a problem. Number 5 and 6 are notorious for sinking into the block, and that's really, really bad on the old E models where they didn't have sufficient coolant flow at the back of the block, and so the excess heat back there made them more likely to fail. So Cat, in order to give you the option of when you're reassembling your engine after a head gasket failure, they do offer a spacer plate that's 3/1000ths of an inch thinner than the stock one that it was built with. So you got to clean everything up really good and take measurements and make sure that you got consistent protrusion from front to back and around each cylinder, because you want no more than, I think, 1,000, or at least what we shoot for, no more than 1,000ths difference around a single cylinder. And we really like it to be that way between all of them. I think Cat says you can have as much as 2/1000ths of an inch difference between the front to back of the block in protrusion. So you know, we kind of like to take all of Cat's measurements and divide them in half and make them tighter. So so anyways, we take measurements all the way across and see how close they are, and often we have found that we can get away with just putting a thinner spacer plate on, and the engine's good to go till, you know, it's ready for a rebuild or whatever comes next. But sometimes they're just too out of spec, or you get you got a liner that needs replaced, whatever, you pull it out and the block's degraded, and so in that case, if it's just way out of spec, we got to cut the counter bore, and that's what's been done on 5 and 6 on this engine already. So what you're doing is your liner's sunk too low into the block, and so say it's reading 1/1000ths protrusion and everything else is reading 4.5 to 5. So you want to raise the sunken liner another 3.5, 4/1000ths of an inch, so it'd be uniform with the ones that are good. So we pull it out, tear it down, and you set your tooling up and cut that groove in the block. And so say we got a 31/1000ths thick shim and we want to raise the liner for 4/1000ths of an inch, so we're going to cut a groove in the block of 27/1000ths, so that when we take 27/1000ths plus 31, it'll give us 4/1000ths protrusion. That shim will be 4/1000ths of an inch above the block. When we assemble everything, it'll just raise that liner up that much, and we got uniform protrusion again. So that's the whole deal with importance of protrusion, how you get what you want. So I guess the last thing to show you here would be how to measure protrusion. So you gotta clamp this all down tight so that you can get an accurate measurement. So we just take Cat sells these special fiber washers that have a little bit of give on them, because you do have a height difference, hopefully, between the liner and the spacer plate. So we tighten these down to 75 foot-pounds. Ideally, kind of like to crisscross. And then we've got a sled with a gauge on it. Now, if you watch a lot of people, they're going to take their reading with their sleds set up like that. That is a really bad idea, because there is a whole lot more reason or opportunity for a bad reading putting your sled on the spacer plate or block of any engine. Instead, you want to put it on this nice brand new liner. The top of that liner, even if it's used, you're going to have a better chance of having it perfectly clean and flat and straight. So we set it on there, and doing it one-handed is making it a little more difficult for me, but we zero out the gauge, and you can see with one hand it's even hard for me to steady the gauge. So we're reading just a little less than 1 right there. If I had 2 hands, I would be straightening it out to 0. But you just run it back and forth over the lip of that liner, and you try to work it until you feel like you've got a constant reading that you're confident in. But you do have to be careful, because wiggling that sled just a little bit just throws that reading way off. I don't think I'm going to be able to pull it off very easily one-handed here. Oh, yeah. So anyway, I have done that. You want to take that reading at 4 different places on the liner and record each of them, and then do it for each cylinder, which I have done. And on this one, I have got readings as low as 4.5 all the way up to 6. Cylinder 2 was the highest, and cylinder 6 had some of the 5 and 6 had some of the lowest. So and again, this has the thin spacer plate on it, and I am putting a fire ringed head on it. So really none of those readings are ideal, and so I'm going to cut the counter bore on all of these. And I'm kind of happy to do that anyways, because the shim will give the liners a new surface to sit on. It'll just be a fresh surface for everything. It should produce the most reliable seal on that fire ring, I guess, make for the healthiest engine. So I guess the next thing to do is I'm going to tear this down and get the tool out to cut the counter bore and go through that process. So by the end of the day, I touched up number 5 and 6 cylinders and cut them about 1/1000 deeper than what they were before, just to dial in the protrusion right where I want it for the fire ringed head. And then as you can see, I started cutting on the number 4 cylinder. I'm not all the way there yet. I'm not going to go into what all's involved in using that tool. There's a fair amount to it, and just I don't think anybody's going to be that interested. But there is a few things I will say, just on the off chance anybody ends up buying or using one of these for in their job and life. First thing I'd mention is so when I bought this, There's two options. There's one with this big base that uses 4 bolts to hold down. They had another version that only used 3 bolts, more triangular in shape, and a smaller base. I thought, well, a bigger base means that it's going to average out the flatness of the deck better and cut a little truer, hopefully, you know, bigger footprint, better performance. Well, it ended up really biting me, because when you're working inside of a truck, or on an engine still inside the truck, you got a gear case here, and that gear case will interfere with the footprint of that, and you can make it work. We've got methods to get around it, but it's a pain. And so I would recommend buying one with the smaller base. Then the other thing I would recommend is, if you're operating one of these, a lot of guys will grab a 1/2-inch ratchet and socket and turn it using this nut here, which you can do, but I would recommend don't get in the habit of doing that, because eventually what will happen is you're going to put a stress and a lean into it that is going to pull on it and wear out the bushings in this over time. I mean, you'd have to do a bunch in order to accomplish that, but I know the Caterpillar here nearby, their tool's worn out, and they gotta be really careful or they'll cut the counter bore into the block crooked. Having said that, there is a time when you want to use a ratchet and a socket, and that's when you're working in some truck that has half the engine underneath the cab and you don't have space to use 2 hands in this handle. I just prefer not working on that type of truck, but I guess we don't get to pick our jobs too much. Anyway, as you're doing it, use 2 hands, use slight, you know, downward pressure as you're doing it. Go slow and steady, and only try to cut maybe 0.02 at a time or so, because if you try to take too big of a bite, your cutter blade will hop, and once it starts bouncing, it can be a pain getting it to smooth out again. And if you're getting to the end of your cut and it starts bouncing on you, you probably just don't have to keep cutting until it smooths out, which is going to be deeper than what you wanted to fit your shim. You got to get a bigger shim, and it gets to be a real hassle. So yeah, just slow and steady, and just check and recheck your measurements as you're cutting. There's enough space right here to to get your dial indicator to measure the lip as you're cutting, and so you can measure as you go, and double check. There's a way to know how much you're supposed to be cutting by these collars up there, but the main thing is go slow. This is a tedious job. It takes forever if you're doing it right, but it's what makes the engine build. So anyway, that's what I got done for the day. We also did get a foot valve put in this truck. It's kind of obvious, but a lot of times people don't think about it. But if you got an engine and transmission out, now's the time to do stuff like the foot valve. Stuff that if you had to do it with the truck completely assembled, it'd be miserable. And now that wasn't a bad job at all. So that's another day's progress. A couple more thoughts about cutting counter bores if you happen to be doing an in-frame job. Obviously that crank is going to be in there the whole time, so you got to be real careful. And when you're cutting the counter bores, you got little metal chips going everywhere. So 2 things. One, your crank down there, you have little oil passages in the crank on the journals, we always will find those and stick masking tape over the holes so that we can't get a metal chip down there, because those lead directly to your main bearings. Yeah, it's pretty obvious why. Okay, the other thing is if you have an OEM cylinder pack, they come with these plastic pieces that go in the liners. You can take those out and shove them down in the cylinder hole in the block, and so when the chips fall, the majority of them will fall onto that. And then you just need a chip vac, pneumatic vac deal, and really quickly you can pick up and pull out most of the metal chips and prevent yourself from doing damage to the engine rather than helping the engine. So don't know if that'll help anybody, but cleanliness is so important.